Hi everyone, so today we're going to learn about the application of derivative. So first, we can use the derivative to find the slope of a tangent. For example, find the equation of the tangent to the curve y is equals to 3 minus 2x cubed at the point 2, -1. So first, we're going to write the equation of the curve, which is y is equals to 3 minus 2x cubed. Next, we're going to find the derivative of the equation of the curve, which is dy over dx is equals to, bring the power 3 to the front and minus the power, so 3 minus 2x squared, and then derive the inside of the bracket, which is -2. Okay, so then we will get -6 3 minus 2x squared. To find the gradient of the tangent, we can just substitute the value of 2 inside the equation of the derivative. So at x is equals to 2, dy over dx is equals to -6 3 minus 2 times 2 squared. So 3 minus 4 is -1 squared, so 1, so we will get -6, which is the gradient of tangent. Okay. So next, to find the equation of the tangent, we just use the formula of the equation of function, which is which is y minus -1 is equals to the gradient -6 x minus 2, and we will get y plus 1 -6x plus 12. Then the equation is y is equals to -6x plus 11. So there you go, guys. Second application of derivative is we can use the derivative to find the turning points, maximum or minimum points. So for example, find the turning points of the curve y is equals to x cubed minus 4x squared plus 4x and state whether it is a maximum or a minimum point. So first, we write the equation of the curve, which is y is equals to x cubed minus 4x squared plus 4x, and we must find the first derivative and the second derivative of the curve, which is the first derivative is dy dx is equals to 3x squared and minus 8x plus 4. The second derivative is d squared y over dx squared is equals to, derive the first derivative, which is 6x minus 8. Okay, so at turning points, dy dx is equals to 0. So three x squared minus 8x plus 4 is equals to 0. So we need to derive this equation. We need to factorize this equation in order to find the x of the turning point. So we will get x minus 2 times with 3x minus 2 is equals to 0. Then we will get the x, which is x is equals to 2 and x is equals to 2 over 3. Okay, So to find whether it is a maximum or minimum point, we must substitute the value of x inside the second derivative of equation. So at x is equals to 2, d squared y over dx squared is equals to 6 times 2 minus 8. So we will get 4, which is more than 0. So when the second derivative is more than 0, we know that it is a minimum point. Okay. Next is we find whether x2 over 3 is a maximum or minimum point. Same, we use the method, we substitute the value of x into the second derivative, and times 2 over 3 minus 8, we will get negative 4, which is less than 0. So when the second derivative is less than 0, we know it is a maximum point. Hence, 2, 0 is a minimum point, and at 2 over 3, when x is equals to 2 over 3, the value of y is 32 over 27. Okay, so this is the solution for the question. So the third application of derivative is solving problems involving maximum or minimum value. Given the question, a rectangular PQRS with the length x cm, the width y cm, and the area is 12 cm squared, show that the perimeter of the rectangular PQRS is L is equals to 2x plus 24 over x, hence find the maximum or minimum value of x. So first, it is provided that the rectangular PQRS with the width of y and the length of x, and we know that the area is 12, so we know that xy is equals to 12, and hence that y is equals to 12 over x. So to find the perimeter of the rectangular PQRS is L is equals to 2x plus 2y, and then we substitute the y is 2x plus 2 times 12 over x, and we will get 2x plus 24 over x. Okay. So next is to find the maximum or minimum value of L. So we know at turning points that dy over dx is equals to 0. So first we need to find the first derivative of L. So dl over dx is equals to 2 minus 24 over x squared. So when dl over dx, we know that 2 minus 24 over x squared is equals to 0, and 24 over x squared is equals to 2, x squared is equals to 12, and hence x is equals to plus minus square root 12. However, we can take the negative value because this involves the length and area. So we know that there is only one x, which is positive square root 12. So to find whether it is a maximum or minimum value, we must first find the second derivative of the equation L. So d squared L over dx squared is equals to 48 over x cubed, and then we substitute the value of x inside the second derivative, which is 48 over square root 12 cube, and hence we will get 1.155, which is larger than 0. And when it is larger than 0, we know that it is a minimum value. Therefore, we just substitute the value of square root 12 into the L to find the L minimum. So L minimum is equals to 2 times with square root 12 plus with 24 over square root 12, and we will get 13.856 cm, which is the minimum value of L. So the fourth application of derivative is related rates of change. Given equation is the volume of a cylinder increases at a rate of 2 cm cube per second. So we know that the dV over dt is equals to 2 cm cube per second, and next the height of h cm of the cylinder always twice the radius. So we know that h is always twice the radius, hence find the rate of change of the radius when the radius is 8 cm. So in order to find the rate of change of the radius, which is dr over dt, we need to find dr over dv times with dv over dt. So first we know that v is the volume of the cylinder is pi r squared h. Next we substitute the h in terms of r, which is 2r, so pi r squared times 2r, and we will get 2 pi r cubed. So we can find the dv over dr, which is dv over dr is equals to 6 pi r squared. So given that the radius is 8 cm, so dv when r is equals to 8, dv over dr is equals to 6 pi 8 squared, which is equals to 384 pi. Next, we need to find the rate of the radius, the rate of change of the radius when the radius is 8 cm. So we know that we have dv over dr, so dr over dv will be 1 over dv over dr. So dr over dt is equals to 1 over dv over dr times with dv over dt. So 1 over 384 pi times with 2, and we will get the rate of change of the radius is 1 over 192 pi cm per second. So the last application of derivative is we can use the derivative to find small changes and approximation. So given equation, which is given y is equals to 5x squared, find the value of dy over dx when x is equals to 3. Hence, by using the differentiation, find the approximation of 5 over 3.01 squared. So first we need to find the dy or dx of y. So given that y is equals to 5x squared, which is 5x negative 2, so dy over dx is equals to negative 2 times with 5x negative 3, so we will get negative 10 over x cubed. So find the value of dy over dx when x is equals to 3. So when x is equals to 3, dy over dx is equals to negative 10 over 3 cubed, which is equals to negative 10 over 27. So we know we need to find the delta x. So the delta x is 3.01 minus 3. Delta x is equals to 3.01 minus 3, which is equals to 0.01. Okay, so to find the approximation of 5 over 3.01 squared, we need to use the formula, which is y new is equals to y original plus with delta y. So we know that y new is 5 over 3.01 squared. Y original, we just insert 5 over 3 squared, and then delta y is plus with dy over dx times with delta x. So 5 over 9 plus delta dy over dx, which is negative 10 over 27, times with delta x, which is the small changes of x, is 0.01, and we will get 149 over 270. So that's it, and I think that's all. So thanks for watching this video, and I hope that you will learn something from my video. So thank you.